Hello class, today I would like to show you how to create the detailed drawing for the part that you see on the left side of the screen. In our class it is known as project 2.3. 2.3 is this item right here. It is the half sectional drawing that's going to be due on 4/9 of 20 for this class, just so you know. Okay. This particular part, when we lectured on its creation, we talked about how to build it. We started with a revolve. We did that by creating the sketch. I'm just going to quickly walk you through that just as a reminder. The sketch that was created involved having elements for diameter. Remember how how that was achieved? That was achieved utilizing a centerline. Please remember that. You have to use a centerline in order to be able to give you a diameter. These are all the other dimensions that were part of that drawing. All of them are based on the drawing that you were using. After the revolve was created, you went ahead and created the next part, which was the rib. The reason we created the bottom rib inside the part, okay, remember that. This was created down here because that rib is right here. Okay, that's where that rib is. This rib is this one over here, okay? So when you see this rib, sorry, that's trying to create an oval. Erase that. That is represented by this piece right here. So please make a note. The reason we did that one was because the other two ribs, there's a total of 3 of them. I shouldn't erase that piece. But they're 3/8 of an inch, and there's quantity 3, so the other 2 ribs are not located at a 6 o'clock position or a 9 o'clock position or a 12 o'clock position or a 3 o'clock position. They're located in odd spots. So to make life easier, we did just the bottom rib. We made sure that it was a closed loop. See that? And that was extruded. Okay. Then after that, because you see it had the little steps sticking out, in order to clean those off, as well as the little steps at the bottom, so they stick out too. And this particular drawing called for the rib to be curved, and that was apparent in the drawing because of the nature of how this is tangential, this curvature. So the dome, the ribs actually married with the dome right here, this area right here. So because of that, these 2 spots, you need to have a tangential component. The only way to achieve that is with the next step we did, which was before that, sorry. We did do a pattern. We did do the circular pattern, so you have all 3, and then we did a circular revolve that wiped out the edges by creating a cutting feature. You see this feature on the outside? This feature was what we used to basically revolve around the center to use as a cutting tool. Very similarly, in the real world, we would have put the part on a lathe, spun it, and then the cutting tool would have cleaned it up. So essentially that's what we did in CAD-Landia version, and had the cutting tool go around the part. The last, well, not the last step, but the second step was putting in the hole. The steps that were missing in the last video that's on YouTube already are adding in the keyway and the last set of holes. There's 3 of them right here, those holes. I'm going to actually start the detail drawing before adding these in and show you how to add them in after the fact. So to create a detail drawing out of any part file or assembly file in Solidworks, you need to just simply go up here, go over to the second option. Let me maximize this so you can see this. You can either go to the Word Solidworks and see the drop down menu, or if you know which icon you're after, you can jump over to it. In this case, you got to click the down arrow, and you see how it says make drawing from part. You can click on that, and this one will say there is a drawing file with the same name as a model file, and the reason for that is because I already created the drawing file, and that's this one over here. Okay, because that's, I think, where we left off when we had class. I'm going to X out of this and not save it. I'm actually going to go ahead and delete that file so it doesn't argue with me. Okay, that way I won't get that question again. Instead, now it'll say make drawing from part file. It'll actually say what do you want to make. Now in my case, I did create a template. It's called Sharis. What you need to remember is I asked you guys to create a template as well, and there's a video on that. It's a 7-minute video on how to create a template, so I expect you to use your template. So I'm going to click on Sharis and hit OK. And the template, what's unique about it is that it contains a petite corner, in the corner, out of the way title block instead of a massive title block with lots of content. It's a very simplified title block. It'll have the scale, the drawing number, revision for when you need that. Your name needs to be on it, and the sheet. And the size of paper, it's an A-size paper. When you open the title block, the border, you'll have the option to bring in your views. The only view I'd like you to bring in is the right side view, but it needs to be put in the correct spot, the right side. Okay? Just bring that one view in. Now the scale's pretty tiny, so the next thing you want to do is change the scale. There are two ways to change the scale. You can click on it, of course, and go in here and change the scale here. Right now it's based on sheet scale, so instead of changing the scale here, I'm going to change the sheet scale. The way to change the sheet scale is you put your mouse over sheet, just click once with your left mouse button, right mouse button, edit, sheet, format. Okay, now when you do that, I actually went in to edit the content in here. That's not what you want to do, so you X out of that. So what you do is click on this right mouse button, properties. See how that happened? You pick edit sheet format. Why? Because it's right there. It looks convenient. But when you do that, you find out you're editing the sheet. I guarantee this will happen to you. Don't worry about it. Just appreciate, okay, wait a minute. I'm here, which means I got to get out of here, go back over here, click once on this with my left mouse button, right mouse button, properties. When you click on properties, that's the sheet itself. You can actually change the name of the sheet if you wanted to, but here's where you also change the scale, the type of projection, the first angle versus third. In our case, this is an inch drawing, so we're going with third angle. The scale, for fun, let's pick 1:1 and see what it looks like. If we don't like it, we can fix it. If I hit apply change, there you go. Well, 1:1 looks a little too imposing. It looks like it's taking over the drawing. So let's change that. Again, you click once with your left mouse button on sheet 1, right mouse button, and change it to properties with your left mouse button. Scale, let's change it to 3/4. And we hit apply change. That looks a little more manageable. If we find out that it still won't work, we'll have to adjust it again. The next thing I always recommend you do is change it to make sure that you're showing hidden lines. The way to do that, I won't just do it, I'll actually slow down and show you. You click once on the view, When you look to the left with all your options associated with the view, you can scroll down and you see everything. Display style, here you have hidden wireframe. Next to it you have hidden lines visible. That's the one you want to select. And then next to that is hidden lines removed. That's the one we had. Then there's shaded, different types of presentations. It's the second option you want, which is the hidden lines visible. Okay, that's the one you want. Scale, now it says use sheet scale, so that's good. Whoops, accidentally moved the view. Let me fix that. Sorry. Where was it? Here, high quality, use sheet scale. Dimension type projected is fine. Cosmetic thread display, right now we're not going to do that. We're going to leave that alone because we don't have any threading on this drawing. When we hit OK, there's our view. To draw the right side, I'm sorry, what technically is the front view because we're on the right side view right here. We've got our center mark here. See that? If we take our little grips, come on you. Come on. Doesn't want to pull out. There we go. You have to hold on that little square, the end grip, so you can pull that out. Then you will have your center mark right there. When you want to create a half sectional view, you'd actually go into View Layout, which is the left tab here. This is Standard Views, Model View, Projected View, Auxiliary View, and Sectional View. That's the one we want. When you click on Sectional View, you'll have choices. You have Section, and then you have what's called a half section. In our case, we want a half section. When we compare our drawing to what our customer has been looking at, see, they've given us something, whoops, they've given us something with a half sectional view so we could see basically a piece of this. Okay? So to do that, over on this side, that's why we're picking one of these, the half sectional options. The question is which one would we want? So we're going to pick this one right here, which is the first half sectional, top side right. Let me open this up. And the next thing we're trying to do is show to the computer where I want to slice it. So I want to slice it right there. Okay? And then it literally will pull that view out to the side. And there you have it. That's the easy part. If you did something you didn't like, let me just okay out of this. But then I'm going to say, no, that's not what I want. I'm going to delete this and get rid of that. Just say, yeah, I want to get rid of it. And then let's say, oh, no, you know what? I changed my mind. I really wanted that. So if I go to half sectional, I pick this again. Let's say I accidentally picked down here or across over there. And I've got this one out here. I'm like, oh, wait a minute. No, the cut's in the wrong spot. Okay, no, that's wrong. So I got to delete it. And every time you do this, you're going to find out that the letter reference for your sectional view keeps changing. Okay, I'm going to do this one more time so I'm not do it correctly. Click on here, drag it across, click over here, and I say, yep, this is what I want. I hit OK, and then I'm like, holy cannoli, why does it say section C-C when this is my first real sectional? Well, the first one you created was AA, the second one was BB, the third one ends up being CC. Let's say you took 5-6 times to make this, so you just go down the alphabet, A, B, C, D, E. Fifth time, you would see section CC. So you have to actually correct that. You do not want to turn a drawing in that has a section CC as your drawing, and that is the only sectional view in your drawing, because people will be asking you, well, where is section AA and where is section BB? Because that is the standard drafting approach to drawings. If I see a sectional CC, that means there should be a BB and an AA somewhere in my drawing. Obviously there isn't, so what's wrong? You need to remember not to either make too many sectional views by accident, or number two, because they do happen, correct your sectional views to the correct letter designation that you want that sectional view to be. In this case, we want it to be section AA, not CC. So you want to make sure you remember to correct that. So when you do that, you're over here. If you double click on the little letters, see, when you double click on it, you'll notice that it appears over here on the left side. Don't manually change the letter in here. Change it here. Okay? When you change it in here, for example, I'm going to change it to Daffy as in Daffy Duck. Okay? You'll notice it turns now to Daffy. And now it's called section Daffy-Daffy. Get it? When you double click on it, you don't want to change it here on the screen. You want to click away from that. You really want to just click it once, not double click it, so you could change it over here on the left side. And that should be the letter A for section AA. Done. That is a proper way to fix the labeling. Okay, please remember that. Next, I've got my sectional views in, and I can start dimensioning. For example, this is the view I want to throw my dimensions in. I go up here to the tab called Annotate, and then I go and pick Model Items, remember. Okay, import items into all views, entire model you want to select. Again, import items into all views. What do you want to bring in? Mark for drawing, just bring in all the dimensions, right? Oh, not marked or not marked is fine. If you have any Whole Wizard locations, any profile, now watch this. If you select this option, Whole Wizard Profiles, you'll notice here to the right it says Whole Callout. If you click on Whole Callout, you'll notice Whole Wizard Profile toggles off. Whichever one of these two you have on, the other one is off. Just be aware of that. You can pick. I normally would select the one my mouse is on right now, which is this guy. Whole Callout. I wouldn't typically pick the other. You do have a little checkbox here to eliminate duplicates. That's a good thing. Annotations, or if you have any, for surface quality, well details, things of that nature. If you don't worry about it. Reference geometry, that's like where the center lines are in, and different work planes. That typically leave that off for the purpose of detailing. When you're done with making sure to check this off at least, and also how many instances of an object you might have. Tolerances, if you have any, you can turn that on. When you hit OK, it should populate the drawing as you just saw, exactly using the physical setup that you actually had when you created your model. I'm not going to touch anything here. I'm going to leave this the way it is. But I will ask, I'm going to zoom in here real quick. You see how the 0.120 is over here? Okay. See how these dimensions are here? You see how this is over here? See how that is in this physical location? Let me show you what's going on with the model. I'm going to jump back over and look at the model. I'm going to open the part. Okay. I'm going to go into Sketch, right mouse button. I'm going to edit that sketch. Now, this is one of the warnings that I actually gave you guys in class. Exactly the way that you have your model dimensioned, smart dimensioned, exactly the way that you have your model smart dimensioned is exactly the way, and let's see if I could do this. I'm not sure if it'll let me, but I'm going to try. In exactly the same manner, won't let me do it. Okay, in exactly the same manner. Okay, so here's what I'm going to do. I'm going to take a snapshot of this, just so you see it. Okay, see this? This is the image out of the detail drawing. And here, over here, is the image right there in modeling. Now try to put these next to each other. Okay, no joke. Remember what I said? Wherever my dimension is in my model, it will appear in my detailed drawing. Literally, no joke. So you notice here how you've got this here. See here? See where that is? See that dimension? See how close it is to the part? Oh, and fancy that. Look where it is in the model. You see how close it is to the actual part? Same. Look at this guy. See this dimension here? See how close it is and crossing over? And guess what it's doing in the model? No joke. It's exactly the same. Okay? Yes, there are slight variations. This piece, for example, is bending over here, and this is bending not right in the same spot. It's bending over. So there are some minor differences. But generally speaking, they pretty much are where you drop them in your model. That is the reason you hear me say, however way you want the dimensions to appear in your detail drawing, that is exactly how you want to place them in your model. That is also the reason that I tell you over and over again, never delete your smart dimensions from your model. If you delete them from the model, they delete from your detail drawing. And outside of the obvious thing, they also unconstrain your object. They also make it impossible for you to have your dimensions popping into your detail drawing. And remember, the reason you want your dimensions to appear, I'll get rid of that. The reason you want your dimensions to appear in your detail drawing, let me pull these out and clean this up a little bit before I walk away from it. The reason you want your dimensions to appear from your model in your detail drawing, the real reason is you want to be lazy. Okay. I said that. I couldn't say that with a straight face. All of you have known me. You're like, oh my God, that again? The reason is efficiency. That's the real reason. Every time, you see, even though I moved the dimensions in my model, these did not update. You'll notice that, so you're stuck dragging them out yourself. Every dimension that's on this detail drawing, that was placed in here using model items, using this feature right up here, model items, every dimension you see on this detail drawing is a real dimension. That's a driving dimension. So what if I double click on this 3 right here and I change it to 3.5, it is literally changing the size of the part. It is not simply a numeric value change. It literally will update, and you'll see it in a second here, update the physical size of that part. See how the nose extended out here? When I change this to 3.5, this nose extended out. Okay? Literally extended out. If I go in the reverse and send it back 3 inches, type in the number 3 and hit enter, watch how this nose, when I update my drawing, moves right back in. That is the power of this software. Inventor does this, Solidworks does this, ProE does this. All of the 3D parametric model packages do this. If and only if you utilize the model dimensions in your detail drawing. If you manually dimension your detail drawing, you basically have a dumb drawing. You cannot manipulate the model from the detail drawing. Okay? So please keep that in mind. The true power of all these software packages that we're working with, that we teach you, is to be able to drive it efficiently. I jokingly call it, let's be lazy, because efficiency is right next to that. The more efficient I am, the more time I have to do other things. I'm not going to be lazy, but that's why I use that language, just to get your attention. So you'll notice that the dimensions will pop exactly where you put them in your model. And as long as you have dimensions from your model, they will appear in your detailed drawing. So don't delete your dimensions from your model, and try to put them in a reasonable location so that way your detailed drawing presents itself neatly. Now you'll see that this detailed drawing is to 3 decimal places, but if we look at what the customer gave us, their drawing is to mostly 2 decimal places. Not mostly, I think entirely. There's only one dimension they have to 3 decimal places, and that's right there. Right here. The only dimension I see to 3 decimal places is right here. The rib thickness. It's the only place. So what that tells me is I need to basically change the decimal places on this detail drawing. Now people will say, so what? Leave it to 3. Those of you who are fabricators, especially my CNC people, you know what decimal places means. It means tolerance. And tolerance, the greater the number of decimal places, the greater the tolerance. The greater the tolerance to the sales and marketing department mean more expensive. The higher the number of zeros to after that decimal place, the more zeros you have, that means the tighter the tolerance. The tighter the tolerance, the more expensive it is to make the part. Because tolerances demand a level of accuracy and attention to detail that you need to account for in cost. So it's very important to not just randomly leave your drawings to whatever decimal places they are. You want to make sure to set them correctly in accordance to whatever the tolerance expectations are of the customer, because they're the ones paying for this. And if they don't want tolerances this tight, or they're paying for tolerances that are not this tight, don't provide them with a drawing to approve with tolerances that are too high. Either it's going to be too expensive, or your company's going to eat the cost for what they make, and you never want to be eating cost, because then they won't have any money to pay anybody, including you. So be very, very attentive to this. So how do you fix your tolerances, your decimal places? Manually, of course. Sure, you can click on each one and change them on the side. Or, let's see, right there. If you click on it and then go change them here. Nope. I'm too lazy for that. There's got to be a more efficient way to do this. If you go to the top, go to Tools, Customize. It's not in Customize. So when we think about it, where would it be? Where would it be? It's in the top. It would be Tools, but it wouldn't be Customized. You'd actually have to hit your little arrow until you get to Options. The other place to get to Options is up here. Instead of picking the Tools option, you'll notice that if you just leave your mouse, you'll see all the icons. It's that little gear box. The little gear, not the box, but it's a little gear on the end called Options. Same difference. And it brings you to the dialog box where we can affect the decimal places. We're going to go to Document Properties. We're going to go into Dimensions. We just click on it. That's all we click on. And then we find out, well, what's the decimal? There it is. The precision is right here. Primary precision will be 2 decimal places. If we look over here, the arrow size is good. The style, we're going to change the style to open arrow because it uses less toner. Not only does your teacher want you to be lazy, she also wants you to be cheap. When you're going to print this out for somebody, you don't want to fill in arrow, because that'll take up more toner than an open arrow. Just a little heads up. Yeah, I am that picky. It's okay. It's good to be a little miserly. It's not going to hurt anybody. So when you look over here again, precision is 2 decimal places. Arrows are open arrow. Okay. Dimensions are good. 1/8 inch arrow. 1/4 inch length. That's fine. First dimension is 1/2 inch away. Second dimension 3/8. The gap 0.0625. That's fine. Extension lines. Remember, the gap needs to be 1/8 of an inch. Beyond the dimension line is a 1/16 of an inch, 0.0625. So everything looks good. We're going to hit OK. There we go. Everything adjusted. So now we've got the open arrows, we've got the nice gaps. Then you start cleaning up your drawing. Because is this right? Now, if you click on this, you're going to find out that the dimensions inside the part, you actually have to drag it out to the tip. Sometimes you got to drag it all the way out and then drag that little button back in. There you go. To make it snap to the right spot. Click this one. You don't want your dimension inside your part. You want it to the corner of it. Come on. Oh, it didn't catch the corner. I hate it when it does that. Let's try that one. There we go. No, that didn't catch. Sometimes it doesn't want to behave. So you pull it all the way out, drag it back in. Wait till you see the dot. This does not want to pop out where it's supposed to be. Let's try it again. Drag it out. There we go. What I did to make that work, I dragged it close and it didn't want to do anything. See that? So what I did was I took my mouse out here and let go. It went pretty far away. Come on, let's try this again. Okay, one more time. Just grabbing the part now. Hold on, dimension. Drag it. There we go. And I pulled it out and it popped out. So this is part of the annoying part of Solidworks, is detailing. Solidworks is not an easy product to work with when detailing. It does demand a degree of patience. There we go. That pulled out. Okay, this side. Then some people will argue with me, well, why isn't it perfect? Well, nothing in life's perfect, number one. Okay, now I see that and let go, boom. But the other side of it is, remember, this is what makes you employed. The reason the product doesn't show things beautifully is to your benefit. It's not perfectly programmed to be perfect in detailing. And the advantage is that is why you're needed at the company. Because the detail drawings need to get handled by a human being. Okay, boom. Let's pull that out. They're popping up funny. Let's try this one more time. Why does it want to detail where it does? It's because I think where the extrusion ends, at least on this particular element right here. Try that one more time. Does not want to. Is that an 1/8 inch? No, that's more than an 1/8 inch. Try that one more time. Yeah, it really does not want to pop where it's supposed to. Some people will delete a dimension and have the system put it back in. Appreciate that this was dropped in this position. So that's not necessarily, it's not going to get repaired literally by, there we go, right there. By simply taking out the dimension and putting it back in. It does require a degree of patience, so I had to pull it out and it finally popped in the right spot. The next thing you want it to do is pop in the right position off the part. You don't want it to be too close, you don't want to be too far away. Too close and too far away for us is the first dimension needs to be 3/8 of an inch, half an inch away from the part. Second and third dimensions need to be 3/8 away from each other. So your goal is to have the first dimension pop into the correct position. Okay, I'm going to hit save real quick just in case. That's another thing. Get in the habit of hitting save, save, and save often. Get in the habit of hitting save, save, and save often. Oh, by the way, get in the habit of hitting save, save, and save often. Okay? Just a word of advice. from someone who's had enough of their work deleted in the middle of a presentation. Okay, now back to this. I'm going to pull this object out. Let's get back in here. Your first dimension, you're hoping, you see how I'm dragging it up and down? What I'm hoping it will do is snap into its preferred spot. The preferred spot should be ½ inch away from the part. It's not snapping, and neither is this one. Let's see if this one does it. Because they should do it in relationship to each other. Click on that. So in relationship to each other, they should snap into position. If they don't stress out too much. There it goes. Come on, one more time. There we go. Did you see how that little yellow bar appeared? See that yellow bar? It's not, there it goes. It snapped in, but the yellow bar didn't appear. I think the yellow bar appeared because it was referencing off of, I think, the 12. Let's find out. Yes, it did. It referenced off where the 12 is. That's what the yellow bar. This one, though, is snapping. It's a very subtle. One of the things I've tried to teach you guys, there we go, that's in the right spot, is Solidworks. If nothing else about Solidworks is subtlety is the name of the game. It will snap delicately into place, but it won't tell you that it did it. Here's an example of, you see how these arrows are inside? If you don't like them inside, click on them once and click on the little inside dots, and they'll pop out. Okay? If you want to show all your dimensions in one way. But it's very subtle, moving these dimensions out into position. This is an example of a dimension that can stay where it is, because this dimension is referring to the center of this object. This 3, annoyingly, happens to actually refer to how many ribs there are. Why it appears in the middle of a drawing like that is annoying, to say it politely. It's just what it does. This is the 3/8 inch dimension for the rib. All the way in this view. So if I pull these down, the 3/8 inch wide rib belongs in this view. Again, patience as you click on each dimension and fix it. Yes, you might actually have to change every single dimension. Get used to it. Let's try that one more time. I want to grab that node and drag it out here. Let's grab that node. And doesn't want to drag. Hold on to it. When you see the little button, you see I'm going to leave that there for a minute so you can see how it looks. See how you've got that dimension with the little dot? That's how you know you're moving the node and not the object. Click on the dimension, position it. When you see the dot on the node, that's how you know you're moving the node. That one just popped all the way back in to its original position. I'm going to try to drag that back out. These flaws in the product, just appreciate them for what they are. They are why you really get employed. You're helping to clean up the work, not just model the view. You want to generate some really good drawings for your clients to look at, that they can understand what it is they're looking at. So I relocated everything. I think everything looks reasonable. I did not turn on hidden lines in this view because it looks confusing. I'll do it real quick. If I take this view and say display hidden lines, see how confusing that gets? That's the only reason I didn't turn that on. No, you don't have the option of just turn on hidden lines on solid side, not on sectional side. This product is not that defined. If you really, really wanted to do it, because maybe you have a boss who just insists on it being done, the way to do it is, yes, you turn your hidden lines on, and then you literally have to surgically turn off visibility for every object that you don't want to see. See that? To me, that's too much work. I would argue the value-added nature of the clockwork associated to doing that. I would not waste that type of time to go in here and do that type of correction. I would just accept that the drawing itself will look like, oops, let me get out of that real quick. I would accept that that view will not have any hidden lines in it. It would look like that. Okay, that's what I would argue for. But I'm not in a position to argue for you. If your boss insists that they see the hidden lines on the side, that the hidden lines are supposed to be there, fine. Chalk it up for whatever and walk away and just go and take each hidden line on the side that you don't want hidden lines and turn each one off. No, there isn't an automated way to turn them off just on one side. So that has to be understood. Okay? For example, here you have an example where part of the line is a solid line and part of the line is a hidden line. See that? This is a perfect example of where you're going to get all or nothing because the product doesn't understand what you're doing. This half of the hidden line is really symbolic of this solid line in front. You cannot surgically just pick this half and turn it off. The only reason I was able to do it with these was because it wasn't attached to anything. That's also a visible line. Here, however, you'll notice this object right here. See, this one right here, especially in the back where there's no break in the object. If I click on this and hide it, it's hiding that whole line, including the part that's not hidden. You don't want that, okay? You don't want that. Uh-oh. Now let's get back. Now I see. I might have to refresh it to regain that line. See, now that line is gone. See that? So now you got to bring it back. The way to bring a line back is you click on it and bring back visibility. There we go. See how much work that takes? See, but you bring it back and then what happens? The hidden line comes right back with it. You'll be like, wait a minute. Whoops. Why is the hidden line insisting on coming back with it? Because that hidden line is really part of that line. It's too much work. You see how it wants to, let's see, okay. Material classing. Yes, I'm happy with that. Got rid of it again. There's no clean way to detail or to remove so many tiny details. Okay, just can't do it. Leave them in there. Otherwise you end up with, as you see what I'm doing, struggling with more work than less work. Okay, do not do this, please, because you're going to end up with more work, not less work. So, and people, the client's not going to pay you for all the extra work on that drawing. Now you notice I eliminated the view. You might ask the question, well, why didn't I go in there and fix it? Okay, two reasons. One, I don't want to make a 5-hour video. That's the real reason. Number two, there is a point of which is easier to do. Just create another sectional view or really tweak that view. creating another sectional view at this point is actually faster than me going in there and spending the time to correct that view. So I'm going to go ahead and just create another sectional. Okay. Now remember, now it's D. Why is it D? At the beginning of the video we talked about that. Because it's actually the fourth sectional I'm making. A, B, C, D. So I have to go change it to the letter A. This product does not reset. When you pick A, it doesn't say, okay, I'll start with A now. No, it still remembers that this may have been the upteenth sectional view that you created. So you might be up to the letter Z in sectional views, and it's still going even though you're making sectional A. So just please remember that. So now again, I've got to go ahead and put in my annotations again. I pick model items because it's the most efficient way to do it. I pick entire model. I click on import items. I've got everything on. I hit OK and boom, there are my dimensions all over again. So I'm a happy camper. You'll notice that these dimensions came out a lot better than the last batch. Why? One, what did we do? I went back in and changed the model, right? Two, everything else is already set. Isn't that beautiful? The things that are wrong are still wrong. This is still inside the part, so you still have to deal with that. But at least the dimensions are neatly arranged. Alright, come on, you. Wait till it's a node shape. Go back. Wait till you see it as a node. Pull away. No. Come on. See how it's got to be a node. If you drag it away, I sure wished it would be like some other software product I know, which I'm not going to mention right now, where it just, all you do is pick on the endpoint and it pops into the correct spot automatically. Solidworks is a beautiful product, but this is not one of its strong suits. There it goes. It finally popped out in the right spot. Detailing is not the strongest suit of Solidworks. Come on. Its strength is not in dimensioning. It's got a lot of strengths in other areas. Dimensioning is not one of them. So... but be aware, okay, don't expect a lot. It doesn't detail as well as you would like. For those of us that used, there we go, finally popped out. For those of us that have done detailed drawings by hand, one can argue I could detail this faster by hand than I can here using this product. But the power of any parametric product is definitely not in the act of detailing. It's in modifying. Wow. Okay, we're almost there. It's 10 more hours. Alright. I'm going to pull up. Alright, so I'll line that up. That looks good. This popped out. Come on. There it goes. Pops. Right there. So, I'm leaving it. This is a little too far over, so I'm going to pull this over. These dimensions look like they're in a good spot. These are in a good spot. Whoops. The 1 1/4 is in a bad spot. Got to fix that one. This dimension cannot be buried inside the part. There we go. Popped out nicely. This dimension... yes, you know, there we go. Come on. You can do it. There. Nope, not yet, I guess. Okay, let's think about it. Let's think about it. Where you want it. Nope. I'm going to leave this one out here. Yes, it's annoying to me personally, but I'm going to leave it there. Okay, I'm going to pull that number out. It belongs here. Of all things, it really should be part of this note. And I am going to make it part of that note. Sadly, I have to delete this number and just manually input it in there. So I got to take that number out. I always dislike taking out model items because if I ever change anything, it's nice because a model item will update itself. And when I have to manually type stuff in, I'm basically taking a Ferrari and turning it into, I'm going to say a Yugo, and it just doesn't function as well. So in this case, I'm going to have to add this notation just like I have it here, where I've got 3 ribs 120 degrees apart, and then the thickness is 3/8, 3 required. And incorporate both of these elements into this one note to save the use of space. So when I double click on it, that wants to change the number. I don't want to change the number, I want to add to it. So over here on the left side, there's something called dimension text. What's inside the bracket, this item right here, is the actual dimension. So you leave that alone. You don't mess with that. You get to do everything else, but not mess with that. So what you would say here, let me try to move this over a bit. Come on, let's attach to everything. So over in this box area, I want to add in that there's three ribs. They're 120 degrees apart. And the thickness, the width of each rib is 3/8 of an inch. So I'm going to type in 3 in parentheses in front of DIM, in front of the actual number, 3. And you see, whatever you type here starts showing up in your drawing. 3/8, 3, blah, 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 ribs. Okay. And then below it, we want 120 degrees. There's a symbol right there. Apart. Of course, we have to spell things correctly. That's one of the things you have to remember. Apart. Okay, 3 ribs, 120 degrees apart. And this says 3 required, so it's slightly redundant. Now, when I clicked away, see, there's the information, but you'll notice how it appeared. You'll find out right now that this is justify center. That's why it appears that way. So you have to actually select right justify or left justify, whichever is most appropriate. In our case, right justify is more appropriate. It didn't pop out the dimension. You see how it's still stuck in there? You actually have to drag it out. And there it goes, pops into its place. Alright, so 3.38 ribs. Now is 3/8 correct, or is that the only dimension? That one is 375. So this is the dimension that we actually want the dimension to show to 3 decimal places. So here is where you would use that manual adjustment, where I'm simply changing the precision of this dimension, and I hit OK. So now that's correct. All the dimensions look good. They're not, may not be perfectly spaced apart, but they are good. This is good. It's a 0.56 through, and according to the drawing, let's see what the drawing tells us. 0.63. Uh-oh. The 0.63. What's that? Ah, wait a minute. Here's the dimension I was referring to, right here, 0.56. But then we see this information. 0.63. This is the keyway, people. That's the keyway right there. That's what that's referring to. And at the same time, the other thing that's being referred to here, let me clean this up a little bit, is we have this information which tells us the width of the keyway. So this entire thing, if I looked at it in view, it's a keyway that looks like this. Okay. It's in that circular spot. So the 5/8 right here actually is this. And that's what's in the drawing already. That's this dimension right here. This dimension right here. Okay. That dimension is that element. What we need to add is this information that will give us the keyway. The keyway itself is 0.12, so 0.12 is a little less than 1/8 of an inch, because 1/8 of an inch is 0.125, which equals 0.13. We are going to ask the client if they really want it to be 0.12 or 125, but it's easy enough to make it 0.12, and then they have to tell us. The reason I'm questioning it, this is 0.06, which is fine, which is half of 0.12, so that physically works. So I'm going to let that go, but you can always make a notation, because one of the other things to appreciate in our world is the fact that you have to actually make something that's purchasable. So if I go to McMaster-Carr's website, and I'm going to look for keyways, you're going to find out that they're sold in standard sizes. Okay? Keys, they are keys. They're actually like little keys. They're sold in stock dimensions. Okay? Stock sizes. And the smallest stock size is a 1/16 of an inch as far as standard size. And a 1/16 of an inch is 0.0625. 0.0625. And that's the width of it. And then you have 1/8 of an inch. Okay. 1/8 of an inch is 0.125. Now 7/64, let's look up dimension real quick. Not dimension, what's it called? Calculator? Sorry. 7/64 is 0.109, which would be 0.11 rounded to 2 decimal places. There isn't a 0.12 key. There isn't a machine key, stock machine key, that's actually 0.12. So the client may have picked that just because they don't know any better. That never happens. Our job for most engineering firms is to try to assist the client in the best solution possible for the situation they have. We can always do custom keys, but maybe if they knew that 1/8 of an inch key was available, they would be willing to pay a significantly lower price to not have to have a custom key. So it's always a good idea to ask. Sometimes the only time you'll get a chance to ask is with the actual detail drawing. When they view the drawing, you want to make a notation to say, hey, key dimension shown to standard key size of 0.125 in place of 0.12, which was on the drawing. Customer has to verify that that's acceptable, and if they do, then you're good to go. So ask the question. Always ask. The worst that will happen is they'll say, no, this is what I want. And that's okay, especially if they're paying for it. Sure, you can have whatever you want. But if they're not paying for it, and you did not ask the customer, you did not check that you have standard dimensions or standard sizes, and instead you provide them with this fancy schmancy 0.12 dimension, then all of a sudden you're also providing them with a fancy schmancy custom key to fit that 0.12. Not to mention the other side of the key, which is of course a keyed shaft, which is the whole point of a machine key, is having an actual keyed, shaft to accommodate the key. And the whole purpose of that is you're trying to make sure that the round object does not spin in the hole. So when you look at keyed shafts, here's what's going on. They're actually connected together. Let's see if there's an image of two keyed shaft. A lot of times they do this with gears. And a gear, you'll hopefully see them in assembly. See, there you go. The whole purpose of this is it's a set. You have the keyway, which is what we're working on, And then you have the key, which is the purchase item that goes in there. And then you have the shaft itself with the key set in it. And this other image shows you rather nicely. The whole purpose of this is to keep this blue object from spinning freely. You're locking it in place to the other object. That's the whole purpose of putting a key in there. And that's the reason you can spend as much money as you want. You can say to the client, whatever you want is up to you, but you're paying for it. The last thing you want is for you to let that go, and then the client comes back to you and say, well, you said you could make it. You didn't tell me it's going to cost me more. You never want to get caught in one of those situations. So it's always good to question first. So make sure to ask. You ask for the 1/8 inch. Okay? Ask to get the 1/8 inch. If they insist on the other one, they get to pay for it. Okay? So back to this. Come on. Joy of erasing. Erase. Whoop. Oh, that didn't work. Let's erase a little faster. Okay. So now what you're trying to make, let's go back to this. You are looking to make this internal circle, which is 1 1/4. That's the, oh, 1 1/4 is the whole thing. 5, 6. This is 5.5625. That's this thing. That's the circle that's already there. Now what you're looking to add, I'm going to change the color real quick here. Let's use green, because I like green. Okay, there's our center mark. And you're creating a line at an angle, and that is where you're going to add that keyway. And the dimension of that keyway, this dimension from the back edge of this arc, aligned with this line to the front of that keyway, that is 0.63. That is this dimension right there. Okay, keep that in mind. Okay, erase a few things. See, this is this dimension right here. So to account for that, okay, that's how you have to build a sketch in to build that. That's why we hand sketched it right there. If we were in class together, that's what I would ask you to do, is hand sketch it, because if you can't hand sketch it, you're not going to be able to sketch it in CAD, because CAD does nothing for you. You have to know what you're hand sketching here in order for you to be able to duplicate your activities in here. So with this in mind, now the width of this, remember all this information, this we're going to assume, we're going to offer 125 because we're going to ask, remember that, ask. Okay, and this half dimension here is going to be a 1/16 of an inch, because half of an 1/8 is a 1/16. Now the only thing we have is, what angle is this at? What angle is this? This angle, what angle is that? So we don't have that information based on what we have. We don't have that piece of information in our drawing. So what we have to assume, and we all know what assume stands for, it's danger. Assume is danger zone. You have to be mindful of what that means. If we do this, we can go here to here. See that? Made it orange. Okay. So we're going to align this to wherever this rib is right there. See how I made a scribbly? Because I'm not giving you that dimension. It's wherever this is. So wherever that is, again, wherever that is. We can do a number, but I'm not going to, because I want to show you a different way. We're going to marry this rib, this keyway with that rib. And for all of you that are saying, why would you do that? Okay, well, the only reason I would do that is because if I look at where this aligns, and I try to hand sketch, I'll take a ruler out, and I would line this line up. I would line this line up. Okay, this position here We have this position here, and I check roughly where that is, roughly parallel with this. This kind of lines up with it, and I said kind of. Again, what are we gonna get? Verify. Verify. The customer needs to verify that dimension. They have to verify that. All right. We're gonna give them an option. We're gonna explain to them. We lined it up with the rib. Is this correct? If it's not, what angle do you want this at? Because it wasn't provided on the drawing. Okay. That's the way we're going to approach this. So when I go back to this side and I zoom in a bit, how do I do this? Now I'm already in my detail drawing, and I catch that I need to add that. So the way to do this is you literally just go ahead, go to the model right there. You open up the drawing view. Doesn't matter which view you select. You can select the sectional as well. It doesn't matter. But you click on the view, right mouse button, and open part. That's all you got to do. When you open the part, go into isometric is fine. By the way, if you're getting the glass cube, if you like the glass cube, go for it. I don't care. That's your call. Me personally, I don't like it, so I turned mine off, just so you know. So for me, it's just a little too much wiggling around the way that it works. So I'm going to zoom in. This is the face I want to work on. I'm going to create a new sketch on that face. Now you'll notice it did not automatically rotate. The way to get it to automatically rotate, it won't. Just let it go. But the way to get it to rotate to the face you're working on is you go up here where my mouse is, and then you select normal to. Remember that. Or, as you could see on the screen right now, pause for a few seconds so you can read it, and make a note of it. Control 8. I'm not using my key commands because I'm lecturing this on a video for all of you to see at home. That's why I'm not touching my keyboard. I'm trying to do everything on the screen only. So I'm not clicking Control 8. To me, Control 8 is faster, but I can't do it with you on this video, because otherwise you won't know what my hands are doing because they're not being recorded. So I'm doing everything on the screen. So normal to is what you're selecting, and boom, I'm in the right view. Now, remember what I said. I'm going to intentionally line this up right here. Okay? That's what I'm going to do. I'm not going to assume that it's at this angle or some other angle. Whoops, sorry. As I'm talking, it's trying to draw for me. Sorry. So let me delete those. Sorry. Okay, so when we get back to this, I'm going to actually look to align this to this. I'm going to add my keyway there. I know it's trying to think what am I doing. So don't worry about what the screen's doing. It's because I'm using my my pen, and the computer's behind the pen trying to think, what am I doing? This is the first alignment. If I move slowly, it might actually just, yeah, I'll move it. Ooh, yeah, that's a no-go. Let's see if I could draw a line across and a line down. It tried. It's trying to think what I'm doing. You see that? I love technology. Friend and foe every day of the week. Yeah, it's not quite knowing what I'm doing, so I'm not going to try to do that again. But I'm going to draw it instead of trying to do it with my pen because it's confused. It's not sure what my pen is doing. The technology is almost there, guys, but not quite, where I can literally just draw as if I was hand drawing on a board and draw straight in CAD. But as you can tell, it's not quite there yet. So when I'm in this view, the first thing I want to do is create a center line. I'm going to create the center line from the center of my object to the mid point. Now you see that? I'm going to leave my mouse there for a second. Oh no, it won't let me do it. Darn it. I wanted to try to circle it with my pen, but then it wanted to follow where my pen's going. So I'm going to leave my mouse there for a minute for you. See how next to the pencil you see that midpoint? Snap the midpoint. If I move anywhere else, like here, that's intersection. Okay, then we go here, and there's the midpoint, I think. Hold on. Let me try that one more time. I think I left it there for so long it may have gotten confused. Try that one more time. Here to... There you go. That's midpoint. See it when it's only a dot? If it's anywhere else, it's on the point. On the point is not the same as midpoint. That's the one you want. Because that way you know it's dead center to this rib. The reason you want it to be dead center to the rib is if the rib rotates or moves around, you want the keyway to move with it. Okay, then we're going to draw with this circle in mind. So one of the things I always recommend is use convert entities, just so it's one less step. Just bring that circle into your view, into this view, so you can work with it. That way you don't have to draw a circle. Yes, your teacher is that lazy. You're right. Okay? And I want you to be as lazy as me. There's no reason to draw extra objects when you don't have to. Use the objects around you. What's beautiful about doing that is, just let me expound a little bit here, is you see this? See that little constraint right there that says on edge? If the diameter of my hole ever changes, my keyway changes with it. So I'm not just being efficient in the moment by using convert entities to use this circle, this all pre-existing hole. I'm also being efficient for the future when if my customer changes the diameter of that hole because it changed the size of the shaft that they're putting there, the hole size will update itself. That's the power of this product when you do things like this. So that's the reason I chose not to draw another circle. So back to this, I'm going to draw my little shape. Very crude, mind you. I'm going to be slightly obnoxious and make something absolutely horrifying. How's that? Make something that looks like a dovetail. How's that for ugly? I did that intentionally, just so I could show you how to fix it. So how do I fix it? When you click on the center line, not on the it's picking too many things. There we go. Pick on this center line as my reference. Hold your control key. This I cannot record. I'm verbally telling you what I'm doing. I'm holding the control key on my keyboard. I'm going to pick my object. And you notice on the left side how you get all your choices for relations. I'm going to pick the one called parallel. And you see how it's snapped parallel? It's a beautiful tool, isn't it? Then I'm going to pick the other line. Pick the face. Hold on. Let me escape. I'm going to pick only the line. Hold my control key. Pick the same center line. Same option on the side, parallel. Oh, what did I get? I got, as I call it, ketchup and mustard. Why? Because it's red and yellow. So why won't it let me do that? See how it says parallel is fighting it? See that? So I have to click up here and delete it. Okay, now it's not fighting it anymore. So why is it fighting it? Okay, when you look at this, it's got two constraints on it already. One is a point coincident, and the other one is called horizontal. So I already made a constraint, not me, I didn't make it intentionally, but the way I moved my mouse, it automatically assumed where I wanted to put it. So if there's a constraint that's fighting what you want to do, what you have to do is click on that constraint and hit the delete button on your keyboard. And then it goes away. Now you can go back to picking the object, this line, hold your control key, pick the center line, and now you can pick parallel. There you go. And then you hit OK, the little green checkbox. The next thing you can do is pick on this line, hold your control key, pick on the center line. Now, whoops. Now, you see how I accidentally picked the face? And I know I picked the face because it's a solid blue. So on the left side, you don't get really any choices at all. When this happens, just hit the escape key. I've already done it a few times anyways. I'm going to, but I stopped right there just so you see what I was doing. Again, I picked the correct line, hold my control key, pick on my center line. on the left side. This time I'm going to pick perpendicular because I want it to be 90 degrees to each other. So I clocked it to be 90. So now the shape is the correct orientation, but the dimension is not defined yet. Based on the drawing, let me remove all my scribblies. We made an agreement. We did. We're going to ask about this, right? So we're going to make this thing an 1/8 inch wide, centered, so it's a 16th to the midpoint, okay? Now, it's 0.63. Now, 0.63 is 5/8 of an inch. Why? Because 0.625 in 2 decimal places rounds to 0.63, so please remember that. So we want it to stand out 5/8 of an inch, but you'll notice that your center line ends here. So what you can do, you can go ahead and extend the line. Okay. So you see how when you click on your little trim option here, you have extend. So I'm going to extend that line to drop all the way back here. Okay. So I can dimension from here to here. See that? And I can go ahead and identify, and I can just type in 5/8 and it'll do the math for me, make it 0.63. So, and then I'm going to dimension from here to here. That I'm going to make 0.125, or if you wanted to, you could use the fractions, 1/8. Okay? And then I want it to be centered, so I have to dimension one of the sides to make sure it's a 16th of an inch. Okay, so that all looks good, and I hit OK. Now it says it's underdefined. You'll notice down here it says underdefined. Now the question is what makes it underdefined, so let's find out. If I take this and drag it around, that's what makes it underdefined. You see that? It is not aligned with the center of this object. So if I click on this little center mark, hold my control key, pick on the center line, I have the option to make it coincident. When I do that, it clocks over and locks itself into that spot. Now it's fully defined. Okay? Now you might ask the question, who cares? Well, you might make the statement, who cares? I recommend you do. It's always a good idea to have your object fully defined, especially with parametric models, because they can get a little wonky on you if you don't fully define them. So it's better to fully define them than not. Just a word of advice. So now while you've got all this done, I think we're set. We're ready to, I'm holding my middle wheel as I orbit this so you can see me rotate it. It looks like it's ready to go ahead and extrude cut. So I'm going to go to features, and I'm going to extrude cut. You'll notice that it picks elements. The reason it does this is because technically there are multiple spots that I can select to just extrude little sections. So I only pick the tip of the keyway because that's really what I want. Instead of blind, I can pick through all with confidence because I have nothing behind it that I'm worried about. You notice that? If I did have some feature in here that I didn't want to accidentally slice through, then I would pick up to next. And up to next will only extend the extrusion to the next spot. And the next spot is the inside of this dome. Okay, see that? So it'll only go to the inside of the dome. So I'm going to ask that you pick only up to next just so that you become comfortable with not using through all, because through all is like putting a chainsaw to everything. So up to next is a little more discreet, a little more precise. So it's good if you get in the habit of just doing that. When you hit OK, boom, there you go. There's your cut. Now the nice part is if I hit save, by the way, save, and save often. Okay, I hit save. Okay. When I go to my detail drawing, it updates itself, and voila, there it is. There's my keyway, and it's also visible here, and it shows you how it cuts into the part rather nicely. Okay, and if you're wondering why is it cutting in, it's not. It's following the curvature of the inside of the dome. That's why it has that geometry that you see there. That's because that's what it looks like. So when we go over here, there's our keyway. Now we just have to put in the missing dimension. So I go to Model Items, and then I hit OK, and guess what? There are all the dimensions that were missing before, because they weren't there, now appear. So there's your 0.63 dimension. There's your 1/8 dimension. See that? Now if you find this is getting too busy, you can always say, no, I don't want to put the dimension there. You can always just back it out. Okay? That one stay there. And you can, of all things, put in a detail. And that's where you're like, well, how do I do that? You go to View Layout, and in here, we've done sectional views, and now we have something called a detail view, and that's right there. When you click on detail view, you can actually make a window, like a little circle. Okay. Now this gets a little confusing for a view that already has a circle in it. I do know that. I understand that, but that's how the product works. And you can go out here, and it'll actually assign a detail right there, and it's called Detail E. Remember, I know it's not a sectional view, but we did have section DD, so the next section slash detail is E, so that's why it says Detail E. So I would recommend going in here and rotating this just a little bit so the E isn't crossing with the center line. Then I would come over here, click on it. Nope, can't click on that. Let's see, let's click on it here. There you go, click on it there. Change that to B. Please remember that you will have to manually change it if it's not already B. And there you have it. Now, you'll notice here it shows you the center line. It shows you a faint circle that defines the detail B. And there's the view. In here now you can go ahead and add the dimensions that are missing that you want to include. So you can go to Model Items, and instead of selecting all views, this is an example of where I pick the view. See that? Click the view. That way it doesn't pop in over in this view, it stays in this view. And you hit OK. So it showed a dimension way the heck out there, so let's pull that in. That's this dimension, so I'm going to delete it from here because I don't need it there. I'm going to include it here because that's where it makes sense to be. I'm going to pull these dimensions out. Now you'll notice that you got to drag them out. Again, the joy of no. Okay, fine, the other way. Drag it out there and then click on this node, double click on it, flip over to the other side. Come on, you can do it. Come on, flip. There we go. Drag you out. And flip. Come on, there you go. Up. Flip again. Come on, you can do it. Just the flip. Flip. There you go. Now, it's still in the bad spot. This view looks good, but it's hogging up a lot of space. So I'm going to click on this view, and instead of it being whatever scale this is at, this view I'm going to change it. Instead of 3 to 2, I'm going to use 1 to 1 because it's a little, yeah, that's much better. It's hogging up too much space. So then I can drag this out a bit, then I can drag this out a bit, because you don't want intersecting lines. Your customer needs to be able to see and read the drawing so that they can approve what you're doing. Now, with that in mind, you already know that you have a dimension in here that is modified. So you're going to click on that, and you're going to put a put a note to C note. See that? See how it says C note? You need to identify that. Now, if you know which note you're going to assign, like C note A, C note B, C note C, whatever it is, this is the place to do it. You want to make sure you identify a note there. In this case, you could just say C note. You could also identify, because the whole thing's unique in the sense that you identify a couple of things about this. You might, let me X out of that, sorry. You might just want to say to the whole thing, come on, a little bit of lag. There we go. Okay. You might assign the reference to the note itself. So if I go down here to this note where it says detail B, scale 101, you can put underneath here C note. Okay? Okay, that would be fine too. Then you can put a note, and literally put a note over here that says note, Keyway made to standard 1/8 inch width. Okay? And at same angle. Whoops. Whenever you have a note like this, you gotta, there we go. Same angle with rib. Whoops, rib. First you gotta spell the things correctly. Customer to verify. Okay, see that? You can put a note in your drawing that says something like that. That would be appropriate. That way the customer will then have to identify, yes, that's acceptable, no, that's not. And you do need to throw in a center line, so the question is, how would you do that? Because you want to identify that this keyway is aligned with this rib. The way to do that is you go under Annotate, and you see how it says center line over here? When you click on that, you can pick the outer part of the rib and the inner part of the rib, and a center line will appear right there. And then you can click on that and then drag that little node through. Okay, see that? And that is how you would identify that. Okay? So that, I think, satisfies this drawing. Except right there, I gotta fix you. You're annoying. Okay, let me fix you. The dimensions are slightly irritating. Just slightly. For someone who's got way too much background and detailing. Alright, there we go. Now accidentally I pulled the 1/2 inch in, so I gotta pull it back out. There we go. So now, some other things to note. See this line right here? This line is the curvature where this curved part meets this side wall. Right mouse button, make it not visible. It's a tangency point, so you can remove tangency. Hold on, let's do that again. There you go. So you can remove that tangency. On this side, it's okay if you leave it because it really defines the 1/2 inch mark. So that's okay. Now when we look at this drawing, the question is, are the line weights what you want them to be? Okay, before you do anything, hit save. Save, save, and save often. Are the line weights where you want them to be? If they're not, now is the time to fix it. The best way to find out if the line weights look good, visually it might look okay. Personally, it doesn't look okay to me right now because it looks like my dimensions pop, but my object does not. It actually should be the opposite. Your object should pop and your dimensions should be subdued. They should be a little bit less poppy. They shouldn't be so bold looking on the piece of paper. So I'm going to do a print preview. So I'm going to go to the print preview. I'm going to say current sheet. I'm going to say, let's see, preview. And let's see what it looks like here. Here it actually looks good. Sorry about that. Here it actually looks good. Let me zoom in on this. Come on. This looks good, actually. So I take that back. This doesn't look that bad. So it might just look bad on the main screen, but on this screen it looks pretty decent. So to verify what it's going to do, I'm going to go back to print. I don't want it to print to a printer because remember, you're emailing your work in. So you pick Adobe PDF. I'll dismiss that for now. Adobe PDF is what you select. When you hit OK, let's see what it does. I'm going to go save it to where it belongs. Which is over here. Okay. Don't need that, but I'm going to hit save. Let's see what it does. So if we look at the PDF, let's see how it looks. This looks good. Your object lines are physically thicker than your dimension lines. So this looks good. So this is fine. In the screen, you'll notice how this is what it would look like as output, but on the screen it looks the opposite, doesn't it? If I put these two next to each other, in the screen version, the dimensions look like they're popping out, but in the PDF version, they look like they're not. So looks can be deceiving is the point. So visually on the screen it might look one way, but printed it'll work out. So don't assume that what you see is what you get. It's not WYSIWYG as the term that is what that means. So just keep that in mind. As you can see, the drawing as I'm working on it doesn't exactly look the same as the drawing printed out. Now what's missing, of course, and if we were in class together, we'd all know it, and you'd all be saying, Ms. Harris, we're not done. I'm missing the holes. The holes on this drawing are missing. So I'm missing these guys right here. So I'm missing these, and there's 3 of them. And yes, you guys had actually contacted me and told me there's something wrong with this drawing. Yeah, you're right. The dimensions are wrong. That they don't actually work, especially if I use this dimension. So this is wrong. There's something wrong with that. So you're going to have to make a note about that to the client as well, because if we follow what they want us to do and use that 30-degree mark, we're actually going to make a big mistake. So because it's going to look wrong. So that is definitely not the 30 mark. So now, to add those holes in, we do the same thing. We actually have to go inside and edit the part again. So we're going to open the part again. Okay. And now we're going to add holes. I'm going to go to the normal 2 view and look at it in this view. We're going to add the holes to that face. So one of the things I remind you when we're together, and I'm going to remind you here on this video, you never go to Hole Wizard first unless you like a lot of work on your hands. And you all know I do not. So I'm going to pick the face that I'm going to drill my hole in first. You pick the face first. I'm going to clap my hands so you understand that. Pick the face of the object first, okay? Then you go to Hole Wizard. You pick the face that you intend to drill through. Then you go to Hole Wizard. That is the down and dirty, get it done. I have too many things on my life to take care of approach, okay? Then I suggest you go to Normal 2 so you can see what you're doing. Identify the kind of hole you want to make. It's going to be a through hole. Okay, so you have to identify that. What diameter, of course that matters. So what diameter is it? Let's find out. 1/2 inch diameter. So you pick a 1/2 inch hole. Okay? Show decimals, no show, I don't care. You do what you want on yours. I have it on. End conditions through all. I do not have any countersinks on mine. Before you're done, you got to go to position. Now, this is the tricky part. Please remember this. Please remember this. I suggest you draw a circle. That's just me. Okay? That's just what I would recommend. Make that a construction circle. Make that a construction circle. Go to Smart Dimension to dimension the diameter of said circle, which is really your diameter of your bolt. BC, your bolt circle. BC, remember, stands for bolt circle. Bolt circle refers to this, the circle that your bolts are on. That's what bolt circle refers to. Okay? It refers to that. It does not refer, as a running joke in class would be BC as a date or something like that. No, it's got nothing to do with that. That's your bolt circle. Bolt circle. Okay? Bolt circle. And that is what I'm dimensioning over here, and that happens to be 4 inches. Okay, by doing that, you've defined where your hole will go. The next thing I would ask that you do is drop in a center line from the center of the object to where that bolt circle meets. So that way you have a perfect spot to drop. Hit escape when you've done it. Come on, you. Hit escape. Go away. Why are you? Okay, sorry. I think that was lag. Let me delete that. Click on this, hit the delete button, there we go. I want that because then my last step will be to actually use point. Point is what Solidworks uses to define the center of where my hole will be. See how wherever I move my mouse, my little hole is moving with me. So when I click that, perfect position. That's exactly where my hole will end up. Dead on. No questions, nothing. And that's it. I'm done. I hit OK. That hole is exactly where you need it to be. Now you're going to tell me, well, why didn't you put all 3 in at the same time? For the same reason I did not put all 3 ribs in independently when I was working on that, because I have a tool called Circular Pattern that I want to use. When I click Circular Pattern, Solidworks does what Solidworks does. Remember what I talked about in class. It's very subtle. Okay. In the case of Circular Pattern, it hops, instead of picking the first item to identify, it hops to feature. So in this case, we want to pick the hole. You can either pick the hole from the model tree, or you can pick it inside your view. The next thing you want to do, and it doesn't tell you this, I know that, that's why I'm telling you, you got to do this for yourself. You click up here with your left mouse button for direction, because now you want to pick the center, the axle, the center of where all your little holes are going to pop out of. This is the center mark. And then how many holes do you want? You want only 3. So remember to identify that. Once you've done these 3 things, the axis, how many holes, and what is it that you're patterning, you're good to go. When you hit OK, you're done. There's your 3 holes exactly where they belong. You go to normal to, and I just flipped it the other way. Now flip it this way. There you go. You see the holes. You hit save, save. By the way, save, save, and save often. When you X out of this, you go into the detail drawing. It updates itself. It's a beautiful thing. The hole appears here. Okay, it appears here. It does not appear here because we don't have hidden lines on. Okay, just understand that. It appears in this view. Now you can go ahead and go to model items. Instead of picking everything, you're not picking everything, you're picking the item. See that? See that? And then you hit OK. The 0.56 through, which you already have dimension down here, appeared again up here. I will delete it because I don't want it there. This is why I used circular pattern. You see how it says 3x, diameter 0.50 through O. It does it well for an object like this, but no, it did not do well for an object like my rib, because you'll notice it appears smack in the middle there again. So I gotta delete that. I'm gonna drag you out again and delete that. Okay? Don't ask me why it works well for one thing and not the other. You'll have to ask the programmers, not me. Now you'll notice your 4-inch dimension is here, but your center line is not here, so that doesn't look right. Why the center line does not carry over, I cannot answer that question. What I can tell you to do is how to put it back up. So if you pick center line, if you pick this one, and you pick an object, it's going to just select. If I select, let's say, 3 objects like this, and I hit OK, it doesn't do anything, because center line only works, that particular center line only works if I'm picking 2 objects, and it creates a center line between those 2 objects. So this feature does not work for this item. The center mark, if I pick this circle, now this one, watch very carefully. If I pick this circle, it puts a center mark just there. That's not what you want. What you really want to do is you pick center mark, and you have an option. If you look at your options over here on the left side, you'll see that you have 3 sets of options: linear center mark and circular center mark. That's the one you want to select. So if I pick this this object, and this object, see how the center mark appears as well? The entire bolt circle center line. See that? That's how you do it. You pick that 3rd option called circular center mark. Okay? Then when you hit OK, it all appears and stays on your drawing. This now actually is the final product. This is the drawing that you want to actually turn into me. Hit save, and save often, and go ahead and print. Adobe PDF. Hit OK. Let's see what it looks like. I'm going to erase the one that's there. I'm going to override it. You're going to see it in a second. Voila! That is the product you want to turn in. Something that looks like that, detailed out, with notes that the customer will have to verify information. Now, did I make a typo? Yeah, bet I did. Right here. I just caught it. Right there. It says 18-inch wide. See that? See, it's like that. It's, what do you call it? Punctuation. I messed up on punctuation. So what do? You don't give it to me. Don't let me catch it. You catch yourself, just like I caught myself. Make sure to add that little, it's amazing how one little slash makes it 1/8 of an inch versus 18 inches. It's a big deal. So now it's correct. Hit save again. And again, print it. And we got everything set. Yep, hit OK. And one more time. Hit save, yes, replace it, and voila, there you go. This is what you'd want to turn into me. Finished product. Okay, and this ends this video. Thank you much for your time. Any questions, just email me and we'll go from there. Take care. Bye-bye.